Okay, hello student. In the previous subtopic, we already know how to perform the long division method, which is the division algorithm. So I hope you still remember this expression. This is what we call the division algorithm. So this part meaning that usually this one is called a factor or what we call the divisor. Okay, divisor meaning that let's say we take 25 divided by 4. Okay, so 4 times how many? 4 times 3, 4 times 4, 4 times 5, 4 times 6. So 4 times 6 is 24, right? So you get 1. So in this case, the divisor will be 4. Okay. Then after that, the QR is what we call the quotient. Okay, quotient. So the quotient is actually referring to the answer that you obtain on top. Okay, when you do the long division. Then the remainder will be this one. Okay, 1. So there are three things in your division algorithm. The first one is the divisor, the second one is the quotient, and the last one R is your remainder. Okay, so in this 4.2, we are dealing with two very important theorems, which you are going to use after this in order to solve the problem in the later subtopic also. So the two theorems is called the remainder theorem and also the factor theorem. Okay, so the first thing we are going to look at is the remainder theorem. Okay, so the remainder theorem say that when you have a function px, let's say your polynomial, you are given a function, no matter is what kind of power they give it to you, maybe x power 3 or x power 4. When it is divided by ax minus b, let's say this is your divisor, okay, this is your divisor, or what we call the factor. So when you divide by this one, when you perform the long division, eventually you will have a remainder. Okay, so the remainder based on this theorem, it says that it's actually equal to P B over A. Okay, so P B over A meaning that this one, the B over A is actually obtained from the divisor just now. So the divisor, let's say you use AX minus B to divide the polynomial, right? So this one, when you make it equal to 0, you actually get AX equal to B, X equal to B over A. That means this B over A is actually one of the roots, okay? One of the roots of the polynomial. Roots meaning that is the answer for x. Okay, is the answer for x. So when you substitute the value of x, which is the b over a, into your polynomial, the x values, the answer that you obtain is actually your remainder. Okay, it's actually your remainder. So if you go back to your division algorithm just now, like for example, you said that 4 is the divisor. Okay, the 4 is the divisor. So, and your polynomial is 25. So when your polynomial divided by the divisor, divided by the 4, you actually get a quotient, right? And then the answer is 6. What it means is that, right, the 4 times 6, you actually get 24. And then you still have one remainder, which means that if I don't have this remainder, okay, the 4 will be a nice factor, okay, will be just a factor of this 25. So same to this one, when we have the remainder theorem, remember that when we divide by a factor or a divisor ax minus b, the remainder can be easily obtained by substituting the values of x from the divisor, meaning that you make this divisor to be equal to 0. Okay, and then you solve for your x. So let's say you solve for your x, it will become b over a, right? Then you substitute this b over a into your polynomial. Okay, which means that you substitute into the equations given to you, substitute into the x, and then you find your answer, and that answer will be your remainder. Okay, so if you are still not sure, let's look at the example here. So actually this one, the question said that let the px, the polynomial, equal to add x to the power of 3 plus 22x squared plus 11x minus 7, and find the remainder when px is divided by, okay, the first one given to you, the divisor is x minus 1. So this is your divisor. Okay, if you did not learn a remainder theorem, what you are going to do is you will perform your long division. So your long division is that what you need to do is do your long division first. 8x cubed plus 22x squared plus 11x minus 7. And then you divide this whole thing with your x minus 1. I'm sure that you know how to do this one already since we have discussed it in the previous subtopic. So the first one, let's say you want to remove this 8x cubed, right? So that means if you look at the x here, you should multiply by 8x squared for your factor. That means x minus 1 should multiply by 8x squared. So 8x squared times x, you actually get 8x cubed. And then 8x squared multiplied by -1, you actually get minus 8x squared. Okay, then after that, what you need to do is you minus, right? So when 8x cubed minus 8x cubed, no more. Then the other one, 22x squared, minus become positive, become plus, right? So 22x squared plus 8. So you actually get 30x squared. Okay, so you have gotten the first remainder. Then after that, you bring down your 11x. So when you bring down 11x, now you compare with the divisor. So let's say I want to remove this 30x squared. So that's mean I have to multiply my x minus 1 with 30x. That's mean I have to put plus 30x here. So when 30x multiplied by x, I actually get 30x squared. Then the other one, 30x times -1, I actually get minus 30x. Okay, which will get back the same number, 30x. Then after that, again, you have to do minus. So when you do minus, the 30x squared and the 30x squared, you will cancel off no more. And the other one, 11x, negative become positive, right? So 11x plus 30 become 41x. And finally, you will have another one, which is 7. So you just copy down the -7 with the sign. And then after that, now you want to remove 41x. Okay, so that means you have to multiply this x minus 1 with 41. So let's say I multiply by 41. So I eventually get 41x minus 41. So what you're going to get here is that you have to minus again. So the 41x minus 41x no more. But the -7 minus become positive. So -7 plus 41, you will actually get -7 plus 41, you actually get 34. So this is actually your remainder. And this is actually your quotient. Okay, and this is actually your divisor. So you have the three things with you. Okay, you have the three things with you. So now you will notice that, remember, your divisor is linear form. Linear form means the x is degree 1, power 1. The x is power 1. The highest power is 1, right? Then if your divisor, the highest power is 1, that means in your remainder is only a constant, meaning that you don't have any x anymore. Because if your highest power for divisor is 1, right? That means the remainder has to be, the power of the remainder has to be less than the divisor, meaning that if the power of the divisor is 1, so -1 becomes 0. So x power 0 no more. So you are left with a number, which is a constant. Okay, now we are going to check whether this is the same as the answer if we use the remainder theorem or not. That means what you need to do is, because your divisor is x minus 1, right? So your x minus 1 equal to 0. So your x equal to 1. That means now you are trying to find the remainder by substituting the x equal to 1 into your polynomial. That means what you need to do is, when you substitute p1, this one will go into the x of your polynomial. So the answer will be 8 times 1 cubed plus 22 times 1 square plus 11 times 1 minus 7. So you get 8 plus 22 plus 11 minus 7. So let's see what you get. 8 plus 22 plus 11 minus 7. So you get 34. Okay, you get 34. So what do you see? You see when I substitute x equal to 1, equal to 1 into the polynomial, and this one is actually come from your divisor, then you get a remainder 34. And this is actually the same as what you did for the long division. So this remainder theorem is actually a shortcut to help you to get the remainder easily. Okay. Then for B, since we already proved, then the B we will do the easier one. So for B, if we have 2x plus 3 equal to 0, because this is the divisor now, so my x will be equal to negative 3 and x equal to negative 3 over 2. So what I need to do is substitute this one into your polynomial, which is the x values. That's me. Now I'm going to check if p negative 3 over 2, what will be the answer? So let's substitute. So the first one is 8, and then negative 3 over 2 cube plus 22 negative 3 over 2 square plus 11 negative 3 over 2 and then minus 7. So you can actually press your calculator for this whole thing. So let me check. Hey, sorry. You can press your calculator also to check your answer. I hope you are following my lesson now. You don't just open and then leave it there and then you go somewhere else. Okay, and then plus 11 times negative 3 over 2 and then minus 7. So I get negative 1. Okay, I get negative 1. Okay, which is correct. Okay, so that's mean when I substitute negative 3 over 2, okay, as the value of x into the polynomial, I actually get a negative 1 as the remainder. Okay, as the remainder. So I hope so far so good. Okay, I already explained to you by using the long division to prove the remainder theorem. Okay, to prove the remainder that is correct. Okay, and you can use it for the rest of the questions already. That means you don't need to do the long division. Okay. Okay, now the next question is still regarding the remainder theorem. When the 2x cubed minus x squared plus kx minus 5, okay, now you see the only difference here is that you have an unknown. Okay, you don't know this number. And it is divided by x plus 2 and give a remainder 1. So this is a very important information given to you. So from here, you can see that if divided by x plus 1, if I use my remainder theorem, that means I have to substitute x plus 2 equal to 0, x equal to negative 2. That means I have to put p negative 2. That means the negative 2 has to be substituted into the polynomial to get the 1 here. So what I will do is, based on remainder theorem, okay, you actually get p times negative 2 equal to 1. Okay, so you have the remainder with you. That means for the negative 2, you just substitute into your polynomial given to you with the unknown. So that means I will do 2 times negative 2 cube minus negative 2 square plus negative 2k minus 5 equal to 1. So you actually get negative 2 cube is negative 8. Negative 8 times 2 is negative 16. And then minus this one become 4. And then this one become minus 2k. And the last one become minus 5 equal to 1. Then you can solve for your negative 16 minus 4 is negative 20. Negative 20 minus 5, negative 25. So negative 2k is equal to 1 plus 25 because you move the negative to the other side. So eventually I get negative 2k equal to 26. So k equal to 26 divided by negative 2. So my k is actually equal to negative 13. Okay, negative 13. So this is like you do the reverse of the remainder theorem because previously they give you the divisor, then they ask for the theorem. They ask for the remainder. But this one, they give you the divisor and the remainder, but there is an unknown in the polynomial. So you have to apply the remainder theorem to find back your unknown k. Okay, to find back an unknown k. Okay, the next one, factor theorem. I'm going to explain with the factor theorem. Okay, so the factor theorem, is the same as remainder theorem. But when we mention about factor, meaning that when your polynomial is divided by an ax minus b, if you say this ax minus b is a factor of the polynomial, meaning that when you do the long division, there is no remainder. When you say, let's say I give you a number 21. And I ask you to list out the factor for me. You will tell me the answer is 1 or 2 cannot, right? Because why? Because when 21 divided by 2, you will get a remainder. And then 3 can, right? Because 3 times 7, you get 21. Okay, 4 cannot, 6 cannot, 5 cannot, and then 7 again. Because 7 times 3, you get 21. So all these are called a factor. So by linking this basic concept to this factor theorem, you have to understand that this ax minus b, when you say that when this ax minus b is a factor, that means you will give a zero remainder, I mean no remainder. It's actually the same like the previous theorem, remainder theorem. Remainder theorem said that when you divide by a divisor, right, you find the x and you substitute, you will get your remainder. Okay, which means that the divisor is not the exact factor. But for factor theorem, when you say that the ax minus b is a factor, meaning that when you do the long division, right, you won't get any remainder. So that means the remainder is 0. So that's why you will have this characteristic. When you substitute the b over a from the divisor into the p, the polynomial, you actually get 0. Okay, you actually get 0. So same thing, I will show you example by using the long division to prove. Okay, let's look at this one. 2x cubed plus x squared minus 7x minus 6. So this is your polynomial. When you divide by x minus 1. Okay, so the question is actually asking you to determine whether the following is a factor or not. Okay, so instead of straight away use the factor theorem, I want to show you the actual meaning of the factor theorem. So what you need to do is 2x cubed plus x squared minus 7x minus 6. And then you divide by x minus 1. So what I need to do is the first one, I want to remove these 2x cubed, right? So what I need to do is I need to multiply by 2x squared for the divisor. So 2x times x, I actually get 2x cubed. And, 2x squared. Yeah? You should put 2x squared here because 2x squared times x, you get 2x cubed. Then 2x squared times negative 1, you get minus 2x squared. So when I minus, the 2x squared will be removed, but this one will become x squared plus 2x squared. So it will become 3x squared. And then copy down the next term, which is minus 7x. So now I want to remove this 3x squared, right? So that means I have to multiply by 3x with the divisor. So plus 3x. So eventually I get 3x squared. And then the 3x times negative 1, I get minus 3x. So here I minus again. So I get negative 7 plus 3. So I get negative 4x. Okay, because negative is positive. I hope you know this. Negative 7 plus 3, you get negative 4x. And then copy down the last one, which is minus 6. So you want to remove the 4x, right? So same thing. You have to, what we call that? The multiply by negative 4. So when you multiply by negative 4, I actually get minus 4x. And then negative 4 times negative 1, you get a positive 4. Okay, positive 4. So if you look at this one, if I minus, what did I get? Negative 4x, negative become positive, right? So negative 4x plus 4x, you will get 0. But the other one, negative 6, so negative positive become minus. So negative 6 minus 4, you get a negative 10. Okay, negative 10. So what can you say about this one? When you get a remainder negative 10, do you think this divisor is a factor? Because according to what the factor theorem said, the factor theorem said that when you substitute the value of x from the divisor into your polynomial, you should get a 0. But as you can see from here, you still have the remainder. Okay, you still have the remainder. So we said that this x minus 1 is not a factor. Okay, or you can straight away by substituting the p times 1 into your polynomial. So your polynomial is equal to 2 times 1 cube plus 1 square minus 7 times 1 minus 6. So I get 2 plus 1 minus 7 minus 6. So 2 plus 1 is 3. 3 minus 7 is negative 4. Negative 4 minus 6 is negative 10. So see, you will still have a remainder. And this is actually the remainder. So we say that the x minus 1 is not a factor. Okay, it's not a factor of that polynomial given to you. Okay, then the other one, same thing. I will do 2x plus 3 equal to 0. So what is your x? Your x will equal to negative 3 and x equal to negative 3 over 2. Let's try to check if this is a factor or not by using your factor theorem. So let's substitute p, negative 3 over 2, into your polynomial. So you get 2 times negative 3 over 2 square, cube, plus negative 3 over 2 square, minus 7 times negative 3 over 2 minus 6. Okay, then press your calculator to check. 2 times negative 3 over 2 to the power of 3 plus negative 1 over 2. 3 over 2, my bad. Negative 3 over 2 to the power of square minus 7 times negative 3 over 2 and then minus 6. Yeah, so you get a 0. Okay, you get a 0. So since your p negative 3 over 2 equal to 0, so 2x plus 3 is a factor. Okay, it's a factor. Based on the factor theorem. This is what we call the factor theorem. Okay, so we already see two theorem, okay, remainder theorem and the factor theorem. Okay, make sure you understand these two theorem before you proceed to do your exercise later. Okay. Okay, let's look at question 2. Okay, please bear with me. I will finish this one. Then later on, you will proceed to do your exercise for the tomorrow lesson. Meaning that tomorrow you don't have any online lesson. Okay, you just need to spend your time to finish the exercise given to you. Okay. So question 2, consider the polynomial px equal to ax cubed plus bx squared minus 1. Okay, where your a and b are constant. When px is divided by x plus 2, the remainder is negative 5. So when the px divided by x plus 2, you get a remainder minus 5. So that's mean, obviously, this is what we need to do is we need to use the remainder theorem. Okay, remainder theorem. So the first thing is ask you to show this one. Okay, you don't need to care anything. So what you need to do is, based on the information given to you, I can find out that when x plus 2 equal to 0, my x is actually equal to negative 2, right? So with the remainder theorem, I can say that p times negative 2, the remainder should be negative 5. Okay, based on the information given to you. Since the remainder is given, so you just need to substitute the negative 2 into your polynomial. So the a times the negative 2 cube plus b times the negative 2 square minus 1 equal to minus 5. Okay. Then now, this one you will get negative 8a and then plus this one 2 is 4, so 4b minus 1 equal to negative 5. So eventually you get a negative 8a plus 4b equal to negative 5 plus 1, you get a negative 4. Then the whole equation divide by -2 because you want to get this form. You want to get this form. So that's why you divide by -2. So I get divide by 4. Sorry, divide by -4. My bad. So you should get 2a, then minus b equal to 1. Okay, so here you already shown. Okay, you already shown. Okay, next one for b. They say that 2x minus 1 is a factor. That means you have to use your factor theorem. Okay, so what you need to do with your factor theorem is that based on your factor theorem, the p, okay, sorry, 2x minus 1 equal to 0. So your x is actually equal to 1 over 2, right? That means this x equal to 1 over 2, if I substitute into your x, you will get a 0 because it's a factor theorem. So that means p times 1 over 2, you actually get a 0. Then substitute. So for the a, 1 over 2 cube plus b 1 over 2 square minus 1 equal to 0. Then you expand this one, you actually get a over 8 plus b over 4 minus 1 equal to 0. So a plus b equal to 1. Okay, so the whole equation multiplied by 8, then you make it linear. So this one we will get a plus this one is 4 times 2 is 8. So it's 2b equal to 8. Okay, so this is equation 2, and your equation 1 is from the previous equation. 2a minus b equal to 1. This is equation 1. So what you need to do is, the equation 2, I do elimination. So 2 times 2. So I get what? So become 2a plus 4b equal to 16. Okay, because times 2 for each of the term. Then after that, you compare with number 1. So your number 1 is 2a minus b equal to 1. So what you need to do is, because I want to remove the a, so I do minus. Okay, I do minus. So 2a minus 2a no more. Negative, 4b minus minus become positive. So 4b plus b, you get 5b. And the 16 minus 1, you get 15. So your b is actually 15 divided by 5. So you get 3. Okay, so you get 3. And haven't finished yet, you only solve for your b, right? So now you just take whatever, which one, from 1 maybe. You can take from the first equation. So 2a minus b is 3 equal to 1. So the 2a equal to 4. A is equal to 2. Let me see my answer correct or not. A equal to 2, b equal to 3. Yes, correct. Okay, so this is the answer. How many minutes already? Never noticed. Okay, let's continue with the next one. Question 3, the expression ax cubed minus 8x squared plus bx plus 6 is exactly divisible by x squared minus 2x minus 3. Exactly divisible means you have to go back to your factor theorem. Why? Because exactly divisible means no remainder, or what we call the remainder equal to 0. Okay, so as you can see, this x squared minus 2x minus 3, right, is actually a quadratic equation. Quadratic, what you can do is, you can actually factorize them. Okay, so the x squared minus 2x minus 3 can make it into, let me see, get used to this method already. Oh, wait. Sorry, should be minus. So x times x squared, so 3 times 1 is 3, so 3x and then x. So if you want to get a negative 2x, so here should be negative and here should be plus. Negative 3x plus x, you get a negative 2x, so negative positive. You just copy over. Negative, positive, negative. So my 2 factorization will be x minus 3 and also x plus 1. Okay, that's mean these two will become the two separate factor of your expression, the polynomial. So that's mean my first one, I will have two information. The first one is p times 3 equal to 0 based on the first one. And the other one, I will do it here, which is p times negative 1 equal to 0. Both equal to 0 because of the word exactly divisible. So let's substitute the value. So a times 3 cubed minus 8 times 3 square plus b times 3 plus 6 equal to 0. So 3 is 27a. And the second one is 3 is square is 9. 9 times x. 9 times 8. 72. And then plus 3b plus 6 equal to 0. So 27a plus 3b. So negative 72 plus 6, you actually get negative 66. So move to the other side, becomes 66. And I'm sure that you can divide by 3. So I get 3 times 9 is equal to 27 plus 1, plus 1b, because 3 divided by 3, you get 1. Then the other one, you get 33. So this is your equation 1. And from the second part also, you have a negative 1 there. So it will be a times negative 1 cubed minus 8 times negative 1 square plus b times negative 1 plus 6 equal to 0. So you get a negative a. So this one become positive, so minus 8. Minus b, because negative 1 times b is negative b, plus 6 equal to 0. So you get negative a minus b equal to, so negative 8 plus 6 is negative 2, so move to the other side is 2. Okay, and what I will do is the whole thing, you multiply by a negative 1 to make it positive. So I get a plus b equal to negative 2. And this is your equation 2. And you can do the substitution, you can do 1 minus 2 actually by elimination. So 9a plus b equal to 33. And then a plus b equal to negative 2. So you do minus. This is number 1. This is number 2. So when you do minus 9a minus a, you get 8a. And this b minus b no more. And 33 minus negative 2, so become positive. So 33 plus 2, you get 35. Okay, correct or not? Did I do anything wrong? Wait. Seems that something wrong. Something wrong. Something wrong. Wait, 9a plus b is 30. Oh, sorry, this is 22. Sorry, this is 22. So this is 22 also. Oh, my bad. So this one should not be 35. 22, negative, positive. So become plus 2, so it's 24. So your A is equal to 3. A is equal to 3. Yeah, correct. Then after that, from 2, you just substitute the value of A. So 3 plus B equal to negative 2. So your B equal to negative 2 minus 3. So your B equal to negative 5. Okay, sorry, my bad. Just now this one, because 66 divided by 3, you are supposed to get 22. If you follow my step, I think you have already discovered the mistake just now. Okay. Luckily, I know I found the mistake. Okay, let's move to the last example before I end the lesson. The term containing the highest power of x in the polynomial is given by 2x cubed, meaning that this will be the highest power term. That means you still have your something x squared, something x, and then with a constant. Okay, and this is a very important information. All this is the factor of this polynomial. Okay, and if you go and do the reverse of this theorem, the first one, the divisor is actually x plus 1. Okay, And the second one is actually x minus 2. And the third one is actually x minus 5. So that's mean when your polynomial is divided by either one of these factor, you actually get 0 because they are the factors of this polynomial. Okay, so you know that this 3 bracket is enough to form your x cube. But the problem is that they already tell you that the highest power x cube, there is a coefficient 2. Okay, so what you need to do is, so your px, basically, you should have these 3 bracket, and at the same time, you should have an a. Okay, you should have an a. So a times x plus 1 times x minus 2 times x minus 5. Okay, so let's, because they've asked for the expression, so you need to expand, no choice. So the first one is, let's expand the first two. So you actually get x squared and then minus 2x plus x minus 2 and then x minus 5. So you actually get x squared minus x minus 2 and x minus 5. And then expand again the last one. So you will get the x squared, so you x cubed. Then the next one will be 5x squared because negative 5 times x squared. And then the next one, you take the second term and multiply with the first term in the second bracket. So you get negative x squared. And then negative, negative, positive 5x. And then minus 2x plus 10. So finally, you get x cubed minus 6x squared. And then this one should be plus 3x plus 10. Let me check and see whether I do correctly or not. Scared. Yeah. So you see, if I multiply back your a into the bracket, right, you will notice that the x cube here, the original coefficient is 1. But it already mentioned in the question it should have a 2x cube. So that means your a should be equal to 2. Right? Since given the term of highest power is 2x cubed, so your a should be equal to 2. And finally, when I put in my 2, so my final expression will be 2x cubed. And then minus 6 times 2 is 12x squared. 12x squared. And then 3 times 2 is plus 6x plus 20. So this will be your final expression for the polynomial. Okay, so this is what I want to explain to you regarding the factor theorem and the remainder theorem. So now is you need to do the exercise. I know that some of you never bring your textbook home, so don't worry. Later on, after you watch this video, you can go to the next page to download the PDF of your questions. So what I want you to do is, you need to do exercise 4.2. Exercise 4.2, your homework. But this one is for tomorrow. That means tomorrow you got no online lesson. What you need to do is to do this one. You do this question. So 4.2, I want you to do question. I haven't decided yet. Question 11, maybe. Question 11 to question 8. Question 20. Yeah, question 20. Okay, question 20. This means basically it's on page 79. Page 79. Okay, I think that's all for today. So remember to do your homework. Thank you very much. Bye.